Talking about FRQ number 1 of AP60 Mechanics 2025, this is version J. It's given that two blocks 1 and 2 slides toward each other, and this is a horizontal surface. Here we have 2V0 m going to the right. Here we have 6m V0 going to the left. They have not really mentioned anywhere that this surface is frictionless or not, or am I not able to find that? Blocks and slides stick together. I don't see it anywhere. Well, that's pretty weird because if there's friction, how can the momentum be conserved? Anyway, right, they're interested in knowing that if the collision happens from 0 to Tc, where T is greater than Tc, then the first thing is they want us to draw FBD, not FBD per se, momentum's body diagram. Before collision for block 1 and 2, and before collision and after collision for the two block system. Now we can see that this goes for what 1 and 2 blocks, right? And we can also see that its velocity is also double. So if we just look at the magnitude, it will be 2mv0, and for here this will be 6mv0. So clearly the second block is 3 times of it. Not only that, it is in the opposite direction because this is in the left and this is to the right. So you have to be careful that obviously it will be 3 more units. So it will be what, 6 blocks, but to the left. So 1, 2, 3, 4, 5, 6. Now I have to draw 4 units to the left starting from here. And since the momentum is conserved, well, I'm hoping that, because otherwise they should have definitely mentioned frictionless surface. But 1, 2, 3, 4, 4 to the left as well because the momentum is conserved. Right, in the next question, they're asking that if block 2 exerts block 1 exerts a force on block 2 that is given by this, then what is the value of F max, and derive F max in terms of all this? Okay, so we know that there's a very important connection, right? That we know that the F average between them is nothing but delta P over delta T, right? That is the F average. So we can find F average definitely, and we have to take on block 2. So block 2 into consideration. We know the initial momentum, that is negative 6 mv0. We don't know the final momentum although, so for that we need to conserve the momentum. So let's come here and then conserve the momentum. Remember that they stick together. So mv0, sorry, 2mv0 minus 6mv0 is the initial momentum, and the final momentum will be 7mv because they stick together, and I'm assuming that it is going to the right. So this will become negative 4mv0 is equal to 7mv. So v will be equal to negative 4 over 7v0. So v is going to the left, obviously, which makes sense. So what is the final momentum of block 2? The final momentum of block 2 will be 6m multiplied with v, which is 6m multiplied with negative 4/7 of v0, which is negative 24 over 7m v0. That is the final momentum. So negative 24 over 7m v0, I'm going to write that here, negative 24 over 7m v0, that is P initial, and this is P final. Okay, what is the change of this? Because that's what we are looking for. The change is the delta P, and delta T we already know. So this change will be negative 24 over 7m v0, negative 24 over 7m v0, minus 6m v0, minus 6m v0 over Tc minus 0, because it starts from 0. Let's do this. So mv0 can be taken out, and 6 minus 24 over 7 times 6 is 42. 42 minus 24, 18. So I have 18 over here, and over 7 is as it is, and over Tc. Now this is F average. Now remember that they are not asking F average, they're asking what is the maximum value of this function. And here we need to use the average value of the function. If you're already doing calculus, you can easily understand that the average value of a function is given by 1 over b minus a, integration from a to b of that particular function f. And that average value is given by mv0 over tc, and 18 over 7 sits outside. So we have to do this now, where b is obviously tc and a is 0, and f is f max sine at. So let's do that. 1 over tc f max sine AT, I don't know what A is, integration, I missed a DT here, integration from 0 to TC is equal to 18 over 7 mv naught over TC. TC and TC is gone. Fm is a constant taken out. Integration of sine is negative cos AT over A. Integration is from 0 to TC will be equal to 18 over 7 mv naught. Right, negative F max over A is will come out. If I put the upper bound, that will look like cos of ATC and minus of cos of 0. Cos of 0 is 1 is equal to 18 over 7 mv naught. So from here, it's just a matter of rearrangement. Let's multiply A both the sides. So that's 18 over 7 mv naught A. And this is negative Fm cos ATC minus 1. Let's divide both sides with negative. In fact, let's give this negative to this guy so that we don't have it anymore. So 1 minus cos of ATC, that is equal to 18 over 7 mv naught A. I'm going to divide both sides with Fm. So 1 minus cos ATC is equal to 18 over 7 mv naught A over Fm. Oh, sorry, why am I doing that? We need to find Fm, right? So scratch that. I'll just divide both sides with 1 minus this thing. So F max comes out as 18 mv naught A over 7, 1 minus cos A T sub C. That's the gross expression that we have. But over here, they're saying that consider a new scenario where block 1 initially slides in the plus x direction with a new speed v1 and block 2 initially again, v0, the two blocks stick together. In the new scenario, the two block system has a constant speed v0 after the collision. So they are saying that express v1 in terms of v0. This is how the situation looks like. I don't really know whether the final speed is to the right or to the left, as in the velocity. I'm going to assume it to the right because anyway, because it depends on how big the V1 is, right? So the math will automatically tell me, depending on V1, it will give me the sign. You'll understand that in a minute. So initial momentum will be mv1 minus 6 mv0, and the final momentum is going to be 7 mv0. They're asking us to use a principle, so we are conserving the momentum, although I keep on asking the question that why is it not given that the surface is frictionless. mv1 minus 6 mv0 is equal to 7 mv0. M is gone, so I'm left with v1 is equal to, let's add 6 v0 both the sides, so that's essentially 13 v0. So that should be our final answer. All right, I hope you guys liked this video. If you did, please like and subscribe. And if you need tutoring, feel free to reach out. Thank you.